everyone. In this video, we are going to be discussing quiz 4. The average was fantastic of an 83%. High was 100% with a lot of 100s, which is great. If you are on the lower end, either anywhere else, make sure that you reflect on why the right answer is right, wrong answer is wrong, and go through the quiz to make sure you fully understand it so that you're prepared for all future quizzes and assignments. All right, let's get into it. Question 1. Match the best term to each of the following descriptions. So this is just, do you know the definitions? So it is get attacked during a reaction. That is our electrophile. The nucleophile does the attacking. The electrophile gets attacked. The electron deficient species, that's the electron poor species, that is your electrophile. Your electron rich species, that is the nucleophile. The functional group that is replaced during a substitution reaction, that is your leaving group. The thing that appears at the start or beginning of a curved arrow, the tail of a curved arrow, is your nucleophile. Your electrophile is at the head, at the end of it. So you go from the nucleophile to the electrophile. The molecule possessing a partial positive charge due to the polar bond, that would be your electrophile. Your nucleophile is going to be the thing that is the partial negative or full negative or has a lone pair. Your electrophile is the one with the positive charges. Question 2. Match each of the following reactions to the reaction class. So reaction A, we see that it is no pi bond goes to pi bond. That is elimination. Reaction B is pi bond to no pi bond. That is addition. I go from having just hydrogen to bromine, so I'm swapping out functional groups. That is substitution. Question 3. The structure below represents a transition state for a reaction between methoxide and 2-bromopropane. So that is methoxide, that is 2-bromopropane. So which bond is being made? Which one is being broken? Well, the fact that this is all concerted tells me it's SN2. So that means that I'm doing nucleophile attacks as leaving group leaves. So I'm making that oxygen-carbon bond. I am breaking the carbon-bromine bond. Question 4. Assign the stereochemistry as either RS or not chiral. So for carbon 1, remember that the priorities are based on your atomic numbers. So I see that there is oxygen, hydrogen, carbon, carbon. Oxygen has the highest atomic number, so that makes it priority 1. Hydrogen's the lowest, so it's priority 4. So then between carbon and carbon, I see this one has 3 hydrogens. And then this carbon has sulfur, carbon, and carbon. So it's going to be priority 2 to the right, 3 is up. So when I connect 1 to 2 to 3, it is counterclockwise with the lowest priority on the dash, that is S. For carbon 2, I'm comparing sulfur, carbon, carbon, and carbon. So sulfur has the highest atomic number, so that is number 1. Then I walk out from that and I see on the left, I see carbon, hydrogen, oxygen. Going up, I get a hydrogen, carbon, carbon. And then down to the right, I get hydrogen, hydrogen, hydrogen. So that means to the left with oxygen is going to make that the highest next priority. Up is going to be next because of the carbon. And then to the right is lowest priority, priority 4, because of all the hydrogens. So when I connect 1 to 2 to 3, that is clockwise with the lowest priority on the dash. So that is R. Question 5, which CH bonds are benzylic? So benzylic means you're one away from the benzene. If you are directly on the benzene ring, then you are phenylic. And if you are away from anything, then you're aliphatic. And if you're one away from your double bond, then you are allylic. So B and D are the only 2 benzylic ones because they are right outside the benzene ring. And then A and E are aliphatic because they are just, there's no resonance or anything associated with them. Question 6, I have a mixture of enantiomers that give an alpha of +4. One of the pure enantiomers will give alpha of +8. So for each of the questions, we're answering as a number. Okay, so what is the percent EE. So that is going to be that it is your mixture over the pure times 100. So that is going to be a 50%. So that is 50% EE. What is your enantiomeric ratio of the positive to the negative? Positive is my major because I see that that's where my mixture is indicating. So that means that I have 50% is pure positive, and then 50% is going to be racemic, positive, and negative. So that means that this is 25% positive and 25% negative. So it is 75% positive and 25% negative. So then the ratio of the positive to the negative is going to be a 3-to-1. Question 7, rank the molecules from weakest to strongest carbon-chlorine bond. All right, so you can think about this two ways. One, the one that's going to be weakest is going to be the one that has the greatest number of substituents that is pushing that carbon-chlorine or the chlorine farther away from the carbon. That is going to weaken the bond using that induction hyperconjugation. We can also think about it as the stability of a carbocation. So if I were to put a carbocation there, the tertiary carbocation is going to be the most stable. So then it had to come from the weakest bond originally. So it means that my tertiary is going to be the weakest, my primary is the strongest, and secondary is in the middle. Question 8, given the following reaction, which molecules act as the nucleophile and the electrophile? Easiest thing to do is identify your leaving group. The group that is no longer attached to the carbon is that iodine. So iodine is the leaving group. So then that means that my iodomethane must be my electrophile because that's the thing with the leaving group. And then the other thing is going to be the nucleophile. That is the ammonia that is acting as my nucleophile. Question 9, determine the following mixture has chirality at the atom, molecule, and mixture levels. All right, so when I look at this, there is going to be a chiral atom. A chiral atom has 4 different groups attached to it. So I see that there is the left side of the molecule, the amine, the hydrogen, and the methyl. Those are 4 different things. And I see the same thing there. So yes, there are chiral atoms. Yes, there are chiral molecules. There's only one chiral atom. So if there's only one chiral atom, you are a chiral molecule. The only exception to our chiral molecules would be meso, which is where you have the internal mirror plane. So that is not meso. There's only one chiral atom. There's no symmetry. That is a chiral molecule. Then for the mixture is not chiral because I have exactly a 1-to-1 ratio, or 50% one and the other and 50% the other, of the enantiomers. So that is racemic. So that is not chiral. That is an achiral mixture. Question 10, arrange the following in order of decreasing nucleophilicity. All right, so this is pretty similar to our base trends. Our most nucleophilic is going to be the one that has the negative charge. Our least nucleophilic is going to be the one with the positive charge, also the one with no lone pairs. That ammonium ion is absolutely not nucleophilic in any way, shape, or form. It can't attack anything. It has no concentration of electron density to attack. So then really we're just looking at, all right, well, between my nitrogen and my oxygen, so I did charge first, then I do atom. Looking at the atom, because our nucleophilicity is very similar to our base trend. So looking at the atom, the one that is less electronegative is going to be a stronger base, which will make it a stronger nucleophile. So nitrogen is less electronegative, so that is the better nucleophile. So, yep, that's everything for this quiz. I hope you have a wonderful break, and please let me know if you have any questions. Right? Bye.